Yeah, hello, Gully Community School Foundations. Thank you for everything that you do for us. We greatly appreciate it. Today, I want to show you a little bit about the BOBOT that I'm asking for a grant with or for. I was introduced to this at the McCall conference. Again, I love going to McCall. Thank you again, Gully Community Schools, for allowing us to go and really be professionally developed with like-minded individuals. And a young lady had this in her class, in her computer science class, and I really gravitated towards it, asked a lot of questions, and ultimately, through the help with K-RISA, they purchased these to work in our classes so that way we can work in teams and go through the iterative process and fail and try again and fail again. But this is the basic BOBOT that we put together. I've been working on programming it myself. And what's cool about these is we work through learning Python, a great computer language, to learn some of the basics of programming, which then cross platforms with a lot of different other languages. So just like learning English and Spanish and French, we have different syntaxes, and that's what these do. This is learning a language called PBasic, so that way we can take those variables and those functions that we learn in Python and just see a little bit of a different syntax when we go to program our BOBOT, as well as with our Arduino boards. Again, thank you for helping with those as well. Our Arduino boards, they use a program called C++. Again, we can take that knowledge from learning Python and transfer that over to different computer languages, and it's great to have on your resume. So this is something I really want to continue to grow with. I have a couple videos that I have been putting together as I've been building it and learning it. I will then put together these basic videos here so that way students can see kind of what I'm going to be expecting of them when we go through different processes of this. And this is... I don't know if you can hear this or not. Let me put my headphones over here. This is basically me maneuvering this and then ultimately pressing my start button, getting them orientated a little bit with it, but ultimately pressing the button and showing, hey, this is what you're going to be responsible to do before you move on to the next process. So let me go ahead and pause this. And we can jump to, all right, we're going to get a piezo speaker working. And so we work on getting our piezo speaker working. So that way when we start each test, we have a speaker located here. That gives us a little tone. Sorry in your eardrum if that's really loud. And then we get into some of the fun stuff where, all right, we're going to work on basic maneuvers and trying to get this thing to go straight down the line. This is where programming really comes into play, because the iterative process, it's not going to work the first time. As you're going to see, my BOBOT is going off to the left. The teams are going to have to go back to their program. They will have to then work on it to change some of the basic numbers in it, so that way when they go through it again, hopefully it will. Let's see here. Go straight down. Well, Mr. Lang, let's see here. Oh, I was writing about how I wrote down the numbers. All right, here's it starting the program. So again, they go back to their code and they continue to really work on perfecting their code, and as you can see, it's going straight down that line. And what we do is we think on the bigger scale here. I always try to have them think of autonomous cars. Someday, I'm hoping that some of our students may be working for our big major automobile industry, and let me go ahead and pause this, and so that way they can see a little bit about how programming works, and as well as work with some BOBOTs that will allow them to fail, go back to their program, do it again, fail again, and it took me about 6 or 7 times through what we call the iterative process to work on this. So I also have videos. Here's one about a line maze. This is one of the request that I'm asking for, is so we would set up a maze and the team would work on putting the hardware and then coding the software, and you can see they're speeding it up a little bit, but eventually this is going to learn from this. I'm going to go ahead, and it's going through every line right now, but the second time you run through it, you'll see this is going to be the goal of the team. This is called the line follower, and now it is going to go the shortest path. It is not going to go down the other dead ends, if you will, and it's learning from each other. It is learning and programming that into its CPU, all right, or into its memory. So these are some things that I'm hoping that we can do. I also am going to go back to this as I brought this up to you guys. You guys should have a copy of this. And if I click on this, this is a really cool feature for a ping sensor, where it's going to be searching for things and running autonomously. Let's see here. Let me fast forward it a little bit. And I don't know if you can see it. The Bobot is way down there. Let me go ahead and bring it a little closer. But it is looking, you can see maybe the head moving on that. It is looking for obstacles. Again, we kind of talk about the Zumba, or if I'm saying that right, the automatic vacuum cleaner, Roomba, I believe it is. So we kind of talk about how we're using science and technology in all of our different components. It's just not necessarily a Bobot. They can program these into a lot of different components. So this is really fun. And one of the teachers had this at McCall too, and said that students just couldn't get enough of the ultrasonic sensor. Excuse me. Okay, so another thing that I was hoping to see is we got the line follower, or the IR remote. This is really cool for the kids to program this so they can control it from a distance. So after they get their program in, they'll be able to control it with a basic remote control. Also, the gripper. What I want to do here is I'm thinking on a big scale of future cleanups where we can maybe make a Bobot at a larger scale just to go around and pick up maybe trash that you see on the highways. Someday you're going to see where, you know, for safety wise, we have humans doing it right now. Well, it can be very scary on the highway picking up trash. So my goal here is for us to pick up or have a kind of trash pickup type of maneuver that we can add to our Bobot, and you can see the grippers here, and there's a video there that you can watch. And then rechargeable batteries. These do take 4 AA batteries, and so instead of continuing to update those, I was hoping to get some batteries and just a way to recharge them, and then also a way to store these, because we're going to have lots of parts. So I was thinking a nice tote for each team would allow them to be able to put all their accessories in and keep everything nice and neat and whatnot for the next groups to come and continue to learn from each other. So again, that's our Bobot. A lot of fun. The students really like it. Right now I'm working on having it maneuver 90 degrees. So it will have one tire straight and one tire maneuver to 90 degrees. I'm working on my YouTube videos that I'm going to be putting on my website here shortly. And so these are some cool things that we do. And so I hope that you enjoyed this presentation and continue to help our children grow in computer science. Have a great one.